Good evening, everyone. Am I audible? Please confirm me. Good evening. Good evening. How are you all? Please confirm me. Am I audible? Good evening, Jay. Okay. So today we will going to discuss the most important topic of fluid statics known as buoyancy and flotation. Okay. So first of all, I would like to tell you about the course which are running from last 2 and 3 days before, or we can say before Diwali. We have started this course. This is a practice session course, and this is the only course in which we can learn about the concepts and numericals in a very short period of time. So this is extremely helpful for all of you. I am telling you, extremely helpful who are preparing for GATE. If you are not preparing for any exam, then it is not important for you. But if you are preparing for any exam, then it is very important and crucial and turning point for all of you, because in a very short period of time, if you learn the concepts and learn the practice of numericals, how to handle the problem, then it is very beneficial for students. Okay, so we are starting this question with the help of very first question. Read the question and then we will discuss each and every point regarding the question. Read it. In the problem, it is clearly given this is a cylinder, mass 10 kilogram. Yes, it is given 10 kilogram, and area of cross section 0.1 meter square. This is 0.1 meter square. Area is 0.1 meter square. Okay. Area of this cylinder is also given. Is tied down with a string in a vessel containing two liquids as shown in figure. Okay. Calculate the gauge pressure on the cylinder bottom. First of all, you should learn how to handle the question. I will tell you. I am telling you, listen carefully. In any question, either it is come from fluid mechanics, strength of material, thermodynamics, or any other subject also, you have to focus on what is calculating, what we have asked to calculate. In this question, it is given that calculate the pressure on the cylinder bottom. Yes, here we have to calculate pressure. Okay, then if we understood what we have to calculate, then second step is formula to calculate the thing which is required. In this problem, pressure is asked, so apply the formula of pressure. Pressure is external normal force per unit area. External normal force per unit area. Very first concept is coming. Listen carefully, my dear students. पहला कॉन्सेप्ट आ रहा है, बहुत ध्यान से समझना. स्टूडेंट्स मगअप कर लेते हैं इस चीज को, प्रेशर इक्वल टू फोर्स अपॉन एरिया. बस इसको समझ लेते हैं. बट इट इज नॉट लाइक दैट कि प्रेशर इज फोर्स अपॉन एरिया. नो, सम स्टूडेंट्स कैन relate that pressure is external force per unit area. No, it's not like this also. Other category of students learn that pressure is equal to external normal force per unit area. No, it's also not exactly. What is the exact definition of pressure? Exact definition of pressure is external normal compressive force. per unit area is known as pressure. This is the $1,000,000 concept of pressure. If you understand this, then you will be very great benefit. If you are not understand this, then you will be in trouble in any of the question or any of the interview. What I want to say that this force is not a ordinary force. In the case of pressure, it is external. Remember my words: external, normal, compressive force. These three terms are very important. If you miss any of the term, external or normal or compressive, you are gone. Completely wrong. So first concept in this question which I want to tell you or which I want to clear you regarding pressure. Pressure is external normal compressive force. Why it is known as external? Because it is externally applied. If it becomes internal, then it will become my stress, and strictly speaking, normal stress. Okay, so this force is external normal compressive force. Why it is known as normal? Because its direction is always normal to the surface. Third thing is compressive. Why it is compressive? Because pressure force is always of compressive nature, not of tensile nature. I think this point is clear. Very good. अगर ये point clear हुआ तो very good. Okay, so here we can write pressure equal to normal force per unit area, and this normal force is external normal compressive force. Very good. Now we have to ask pressure as well as tension in the spring. Okay, no problem. Tension in the spring, how we can calculate, I will tell you. Because if it comes in the exam, calculate the tension in the string, person comes in the tension. Now how I will calculate? My mechanics is not so good. I will tell you simple funda. If any question come regarding tension of anything, I will give you. So please concentrate and listen carefully. And rest the things are density of water, specific gravity, and specific gravity of water. These all things are also given in the question. No problem at all. So my target is to calculate pressure and tension. So what the first thing came in my mind is draw the free body diagram. Mechanics ka golden rule. The golden rule of mechanics is draw the free body diagram. Just draw the free body diagram and free. This is the basic and golden concept. Just draw the free body diagram of the system. Here my system is this cylinder. So making free body diagram. Okay. Let me draw the free body diagram of this cylinder. Very good. Now I will apply the external forces on this cylinder. So first force is acting on this cylinder is weight of the cylinder, W. Okay, I think this point is clear. First is weight of the cylinder at the CG, because this is 3D body, cylinder is 3D. If it is a 2D body, then this is known as centroid on that case. Now here it is CG, center of gravity, because it is 3D body. Okay, this point is basic concept of physics. Very good. Now other forces are, here it is tied with the rope. This cylinder is tied with the rope. See, with the help of a string it is tied from bottom. So always take tension in the outward direction, means outward from the body. If this is my body, where we are calculating external forces, or this is my system, then always take tension outward to that body. Always. If this is my body, then always take tension outward. If you are taking upward side, then it is outward, not inward. If you are taking this side, if you are considering this side, then tension is this direction. I think this point is clear. This funda is clear to everyone. Tension is always away from the body. Here my body is slender. So for that body, the tension is in the outward direction. So direction of tension is here. This is tension. Away from the body. I have taken away from the body. So this is W and this is tension. Now, any other force? Any other force? Tell me quick. Because free body diagram means how many forces are acting on the body. Calculate them. So W is well known. Weight of the body, weight of the cylinder. Tension is acting because it is tied at the bottom. Any other force? आपको कोई और फोर्स दिख रहा हो तो बता दीजिए मुझे जल्दी. क्विक जल्दी बताइए बेटा. आप लोग थोड़ा सोचिए, जब तो आप लोग सीखोगे ज्यादा से ज्यादा. थिंकिंग पावर आपको बढ़ानी है अपनी, उसी से एग्जाम निकलता है. ऑलवेज रिमेंबर दिस फैक्ट. ये आपको ये चीज बहुत जगह नहीं बताई जाती है. आप अपनी थिंकिंग पावर बढ़ाएंगे, उससे एग्जाम निकलता है, ना कि अपनी इंफॉर्मेशन गैदर करने से. इंफॉर्मेशन गैदर मींस आप किसी बुक से पढ़ रहे हैं, आप किसी टीचर से सीख रहे हैं, तो आप अपनी नॉलेज को गेन कर रहे हैं. पर नॉलेज गेन करने से ज्यादा अच्छी रैंक नहीं ला पाओगे. आप अच्छी रैंक कब ला पाओगे? जब अपनी थिंकिंग पावर बढ़ाओगे, आप चीजों को एनालिसिस कर पाओगे, तभी एग्जाम में रैंक आएगी बेटा. ये आप अभी समझ लोगे बहुत अच्छी बात है, नहीं तो कुछ दिनों बाद यही लाइन आप दूसरों को बोलोगे कि यस इट इज ट्रू, कि अपनी थिंकिंग पावर आप बढ़ाओगे, उसी से रैंक आएगी. देयर इज नो अल्टरनेटिव ऑफ इट. दिस आई एम टेलिंग यू फ्रॉम माई एक्सपीरियंस. तो बताइए कितना, कौन सा फोर्स इसके ऊपर बचा हुआ है जो लगेगा? जे रिएक्शन फोर्स. तो टेल मी व्हाट इज रिएक्शन फोर्स? टेल मी व्हाट इज रिएक्शन फोर्स? If my body, listen Jay, if my body is here and this is my object, then this is weight of the body, and from the surface there is normal reaction comes. Normal reaction means contact. If the body is in contact, then normal reaction will come in the opposite direction. But here there is no contact, na? So there is no normal reaction. W and T. One force is remaining, known as buoyancy force. Why buoyancy force? Because this body is in the fluid environment, means here there is surrounding, there is a fluid. So this fluid is apply a buoyancy force. This is my fluid and this fluid is applying buoyancy force. What is the funda of buoyancy force? Buoyancy force funda is, if any body is immersed inside the fluid, then that body will experience a net vertical upward force known as buoyancy force. This is the concept. How it will come? It will come due to pressure force only, due to balance of pressure force only. Understood? Due to pressure force. But here this is a practice session course, that's why we are considering only the buoyancy force, not the origin of buoyancy force. Is it clear? मैं यहाँ पे आपको buoyancy force बता रहा हूँ. जब आपकी full flash course होगा, जब आप full flash course करोगे, तो वहां पे आपको बताएंगे buoyancy force आता कैसे. फिलहाल आप याद रखिए कि it is vertically upward, known as buoyancy force. These are the forces acting on this cylinder, this object, this system. Okay, this point is clear? Very good. Ultimate. Now, but here you have to think like this. Here there is a fluid A as well as water B. They have two fluids, means fluid is A having specific gravity 0.8 and other is water. There are two fluids in this. So due to these two fluids, the buoyancy force is acting upward, but here we have to consider the buoyancy force due to both the fluids, fluid number A and fluid number B. This is the point. This is the special point in this question, because there are two fluids and these two fluids is exerting a buoyancy force on this object. On this object. Who are exerting the buoyancy force? This fluid as well as this fluid. Both fluid exerting buoyancy force on this. What is the formula of buoyancy? This is the $1 million question. What is the formula of buoyancy? Buoyancy formula is, listen carefully, density of fluid multiplied by G into volume of fluid displaced. This we have derived beautifully in the full-fledged course. Beautifully derivation you will see if you join the full-fledged course. Then you will learn how this formula will comes. Okay, no problem in that. Now, buoyancy force is density of the fluid multiplied by acceleration due to gravity and into volume of fluid displaced. But here two fluids are there. So fluid number 1 means fluid number A as well as fluid B also. This is the fluid B multiplied by G, volume of the fluid displaced due to B fluid. This is due to A fluid, because there are two fluids. If the question is easy, if the question is very easy, then it is only one fluid is there in the problem. But here question is little bit difficult. So two fluids are given in this question. Okay, very good. I will tell you, Jay. I will tell you. Jay, I will tell you how you will join. 100% I will tell you. No problem in this. So this is my buoyancy force, and if you take care of this part, then you will get the equation. What is equation? Here buoyancy force upward direction, W is downward direction, tension is also in the downward direction. Okay, so I am writing the equation. Please concentrate. FB in upward direction equal to W in downward direction, and tension is also in the downward direction. Now calculate what is the buoyancy force. Buoyancy force you have to calculate by these two formulae. Add both are, then you will get the exact buoyancy force. So tell me, because density is given, G is given, you are facing difficulty in volume of fluid displaced. I will tell you how we will calculate volume of fluid displaced. For fluid A, this is the volume which is displaced by the fluid. This is the volume. This is the volume only. So how you will calculate this volume? This volume is the area multiplied by this height. Okay. Next, second volume is for fluid number B. I am again and again saying this question is little bit difficult because of presence two fluids. If the fluid is only one, then the question is very easy, and I am not here to solve the easy questions. Easy question आप अपने आप कर लोगे, but here I am telling the difficult part in which you are facing the problem. Okay, this is my second. So this is area multiply by this distance 0.125. This is the volume of fluid displaced by the second fluid, that is water. Okay, so this is the first volume of fluid displaced by A, and this is the volume of fluid displaced by B. Very good. Area I think given in the question. Yes, beautiful. 0.1 meter square. Area is 0.1 meter square. Already given in the first line of the question. Very good. Now, so tell me the value of FB, because you know this, you know this, you know this, you also know this, this and this. So you are not facing any difficulty while calculating this. So tell me the value of this so that I can put here the force of buoyancy. Tell me, if you calculate J, if you calculate, you will find the value of F B, that is buoyancy force, is 201.5. 201.1, I think. Yes, 201.1 Newton. This is in Newton. Equal to, what is weight of the cylinder? What is weight of the cylinder? Very simple. Very simple. W equal to mg. This is very simple because you all aware from the fact that our earth attracts us with the help of gravitational force, and value of gravitational force is m into g. That is weight of the body. So this is m into g. Mass is given. Look, mass is given. Very good. This is mass. Everything is given in the question. The difficult part I have already discussed. Rest things are very simple. And G is known to you, 9.81 plus T. So you will calculate mass is 10 and G is 9.81. You will get 98.1. Very simple. From this equation you can calculate tension. So tension in the spring you will get, if you take this side, 201.1 minus 98.1, you will get 103 Newton. So tension will comes out to be 103 Newton. This is my tension. So this part is gone. ये आपने निकाल लिया 103. ये पूछा हुआ था टेंशन इन द स्ट्रिंग, ये आपने निकाल लिया. Second part is pressure on the cylinder bottom. This part is remaining. How much pressure? Pressure equal to, as I told earlier, external normal force. Normal force which is of compressive nature. External and compressive also come. Then it will correct. Divide by area. Which area? Area of cylinder. Because here the pressure is acting now. Here is pressure is acting due to this. So here pressure is acting on this area. So this is the area. This is the area. Area is given already 0.1 meter square. No problem in this. What is the total force? What is the total force? Total force is, tell me, what is the total force? Jay, tell me, what is the total force? If this is my cylinder, so this is the area. But what is the force? If you tell me the value of force, then I will put here. Only that person can tell the answer which learned from me that pressure is external normal compressive force per unit area. So for the cylinder there is W also acting downward, T also acting downward, but we have to consider which force, tension force or compressive force. Tell me, Jay, quick. We have to consider which force. This is the beauty of the concept. Tell me quick, which force you have to consider, this W or this T or FB. FB is acting upward direction. Upward direction means compressive nature. That's why I written clearly. See, external normal compressive force. This is the beauty. Now you understand. So only FB. So here FB divided by area. Area is given in the question and FB is also you have calculated earlier. FB is 201.1 and area is 0.1. So you will get the pressure equal to 2.011 kPa, kilopascal. This is my final answer. Got it? This is the concept of this question. So I have told so many things regarding this. I have told you so many things regarding this question, not solving this question. I am telling the concept of solving the question and what is the concept behind the question also. That's why I message you on the group, come live. Now this is the question session round, doubt session round. This question is over. You can ask me doubt also regarding this question. But if you are see the recording session, then you are not able to ask your doubts regarding this question. That's why I say come live and join live. I always say there is interaction is compulsory for learning. If there is no interaction, there is no learning. I am telling you. Now come to the next part of the second question. This is also very good question. This is a in this question it is given that a spherical balloon with a diameter of 10 meter. Diameter is 10 meter. Shown in the figure below is used for advertisement. The balloon is filled with helium. This is your helium gas inside it. The helium gas is inside the balloon. Listen carefully. Balloon is filled inside the helium gas is filled inside the balloon. This is helium gas. Okay, very good. The balloon is filled with helium at ambient conditions at 15 degrees Celsius and 100 kilopascal. Assuming no disturbances due to wind, the maximum allowable weight of the balloon material and rope required to avoid the fall of the balloon. R of air is 0.289. So these are the data given. Now listen. Again the concept is same. Concept is make free body diagram. Just make free body diagram. Free body diagram of balloon. This is my balloon. So make free body diagram. So what is the free body diagram? Weight of the balloon comes downward like before. Second, buoyancy force acting upward. This buoyancy force is exerted due to this air, atmospheric air. Atmospheric air try to push the balloon in upward direction. So buoyancy force due to this is acting in upward direction. Okay, very good. Now second thing is again tension. Tension is, as I told you earlier, what is tension? Tension is always away from the object. Always away from the object. Always away from the object means this is my balloon. Tension is always away. So it is away from the balloon means downward direction. Okay, this is my T. Direction of T. Now it is clear. This is tension in the rope which is tied at the bottom. So this is my free body diagram. Okay. Now write the equation at equilibrium W plus T equal to force of buoyancy FB. But here one more force is come. Weight of helium, because this is the weight of balloon. So I am writing balloon. But one more force come into picture known as weight of the helium gas, which is also takes place in the downward direction W. This is the weight of helium gas. This is also downward direction, so I am writing here weight of helium. Now $1,000,000 question is how you can calculate this weight of helium gas. Weight of helium gas you will calculate by this simple formula m into g. देखिए बेसिक फॉर्मूला अप्लाई करिए आप हमेशा हर चीज को कैलकुलेट कर सकते हैं फ्रॉम बेसिक। अब देखिए यहाँ पे ये इसमें दिक्कत आ रही थी, आप इसको कैसे करेंगे, m इंटू जी होता है वेट। मास कैसे निकाल सकते हो, मास होता है डेंसिटी इंटू वॉल्यूम, यस और नो, मास कैन बी राइट एज डेंसिटी इंटू वॉल्यूम मल्टीप्लाई बाई जी, वेट ऑफ हीलियम गैस, वेट ऑफ हीलियम गैस इक्वल टू रो वी जी, correct? So this is rho into V into G. V is the volume of balloon, G is acceleration due to gravity. How you can calculate density? Since helium is a ideal gas, helium is ideal gas. So by using ideal gas equation, we can calculate this density. How? Ideal gas equation is PV equal to mRT. In thermodynamics practice session, I have given other forms of ideal gas equation also. PV equal to N R bar T. But here I am using PV equal to mRT. P equal to M upon V RT. It will becomes P equal to rho RT. Very good. Density equal to P upon RT. Pressure, it is given to you, R is given to you, temperature is also given to you. So you can calculate density. So calculate the density and tell me what is the value of density of helium. Tell me by using this formula. Just put the data and tell me the answer. Dear students, put the data and tell me the answer. Just tell me the answer. So density will comes out to be 0.167 kilogram per meter cube. Very good. Now, if density is known for you, then put here, you will get the weight of the helium. What is the weight of helium? Density of helium, volume of balloon multiplied by G. Because this helium is filled in entire balloon. So I am taking the volume of balloon. Okay, this point is clear. Now come to the question again. Here it is given that assuming no disturbance due to wind, the maximum allowable weight of balloon material and rope required to avoid the fall of the balloon. ये बैलून आपका नीचे नहीं गिरे, इसके लिए हमें कैलकुलेट करना है. क्या कैलकुलेट करना है हमको? Which thing we are required? Tell me. Weight of the balloon plus weight of this helium. So tell me. I am waiting for your answer. Tell me this weight of the helium. If you get weight of the helium, then put here. Okay. If you calculate this, then second important thing which you have to calculate, buoyancy force, and buoyancy force equal to rho into G into volume of fluid displaced. Here volume of fluid is atmospheric air around the balloon. So this is my atmospheric air. So this is the formula for buoyancy force. Density of the fluid which is outside, not helium, outside, multiply by G, multiply by volume of fluid displaced. Volume of fluid displaced is equal to volume of the balloon only, because it is completely submerged inside the environment. Okay, so here you can calculate FB also. Now you can calculate weight of the balloon. Tell me. Here I can tell you how you can calculate. This is weight of the helium. This is weight of the balloon equal to buoyancy force. Now this buoyancy force you can calculate by this formula. This buoyancy, this weight of the balloon you can calculate, and this how you can calculate I told you earlier. So tell me the final answer of this question. I am telling you, you will solve, then clarify your answer. Answer is comes out to be total weight equal to 5306 Newton. This is my final answer. Solve this. If you find any difficulty, then you will ask me. You will get weight 5306 Newton or not. The things which are used in this problem, I told you. You have to consider the buoyancy force due to atmospheric environment, and you have to consider the weight of helium also. This weight of the helium. This is the important part or important concept in this question. Rest things are as previous case. Rest things are very simple. The thing which is important in this question is weight of the helium. You have to consider the weight of the helium. That's why I take this question to tell you in this particular question you have to calculate the weight of helium gas also, and in the upward direction you have to consider the atmospheric air. So practice these questions again and again, buoyancy and flotation. Then tomorrow we will meet with some other questions. And one most important thing at last I will like to tell you, practice is the only substitution. Practice is only the substitution of brilliancy. Practice. अगर आपको लगता है कि आप इतने ब्रिलियंट नहीं हो अदर स्टूडेंट्स की तरह, अदर स्टूडेंट्स अच्छे से क्वेश्चन को जल्दी सॉल्व कर पाते हैं, आप लोग नहीं कर पाते हो, तो आप उनकी तरह बन सकते हो. उसका सब्स्टिट्यूशन क्या है? ब्रिलियंसी. आपको लगता है आपके अंदर नहीं है, ऐसा लगता है कुछ स्टूडेंट्स को, तो आपको क्या करना है? प्रैक्टिस करनी है क्वेश्चंस की. प्रीवियस ईयर क्वेश्चंस लगाइए, गेट के अदर क्वेश्चंस को भी सॉल्व करिए, ईएससी के करिए, तो आप अपने आप देखो कुछ टाइम बाद उस चैप्टर में आपको ब्रिलियंसी, आपके कॉन्सेप्ट अपने आप निखर के आएंगे. यही सब्स्टिट्यूशन है, यही मूल मंत्र है. ओके, सो प्रैक्टिस, प्रैक्टिस एंड ओनली प्रैक्टिस ऑफ द क्वेश्चंस ओनली. और कॉन्सेप्ट वो हम आपको बताते ही रहते हैं बीच बीच में. ठीक है, थैंक यू सो मच.